guys, welcome back. Today we're going to learn how to graph linear inequalities in two variables. So this is an extension of what we did last class where we actually work with just one variable. Now we've got two variables, so these are actually going to be equations of lines. So graphing a linear inequality in two variables has an ordered pair that produces a true statement when the values of x and y are substituted into the inequality. So what that means is, say we had example 1, it said which ordered pair is not a solution of x minus 3y is less than or equal to 6. So to determine the answer, you must substitute each x and y coordinate into the inequality to determine if it makes a true statement. So let's look at A. We have the ordered pair 0, 0. So if we have the inequality, let's write it out here, x minus 3y is less than or equal to 6. If we substitute in 0, 0, for x and our y, we get 0 minus 3 times 0 is less than or equal to 6. And then we just follow our order of operations. Well, this is 0. 0 is less than or equal to 6. That's a true statement, so we do know then that it is a yes, okay? So it does satisfy, it is a solution to that. Okay, but our question's asking which one is not. So let's do the next one here. Okay, so we're going to look at the ordered pair 6, negative 1. That's B. We plug it in. Our x is 6 minus 3 times negative 1 is our y. Okay, we follow order of operations. This is plus 3. And we end up with 9 is less than or equal to 6. Well, that is a false statement, so that would be our no. There it is. Okay, let's check the other two and practice. So now we've got the ordered pair 10, 3. Okay, we plug it in. We've got 10 minus 3 times 3 is less than or equal to 6. Well, that's 10 minus 9. 1 is less than or equal to 6, so that is a solution. And then our last ordered pair is negative 1, 2. Let's check that. All right, our x is negative 1. Okay, minus 3 times 2. And that's going to be less than 6. Whoops, running out of space here. So this would be negative 1. Negative 1 minus 6 is less than or equal to 6. Yep. And that would be negative 7. And yes, we do know that that is indeed, okay. So the answer here would be B, okay. All right, so let's try one. If you guys want to try it on your own, you can pause the video, okay, and then play it back and check each one of these. So this would be, we'll just plug in the values. I'm just plugging it into this inequality. It's a true or a yes. Okay, be careful here because 8 is less than or equal to 8, but it is not less than. So this one would be a no. Okay, when we do this one, we end up with 7 is less than 8, so that one would be a yes. Okay, because that's true. Okay, so that's how we know if an ordered pair is a solution. All right, but let's look into graphing. Okay, before you graph, there's two important things to recall. Remember, if an inequality is just less than or greater than, when we had a number line, we would make an open circle in that case. Okay, but if it was less than or equal to or greater than or equal to, we would actually color in that circle. Okay, but now we're taking it to another, instead of just being one variable on a number line, now we have two, so we're making two-dimensional, and we're going to make a line. So the line of the graph is actually, if it's just less than or greater than, instead of an open circle, we're going to have a dashed line. Okay, by dashed, I mean, you know, dash, dash, dash. Okay, all right, but if the graph is less than or equal to or greater than or equal to, the line of the dash is, the graph of the line is solid. Okay, just like usual. Okay, so you're then going to rearrange the problem, always rearrange the problem into slope-intercept form. Only now without slope-intercept form, we need to put it, instead of having an equal sign, we're actually going to have an inequality sign. It's either going to be less than, greater than, less than or equal to, or greater than or equal to. Okay, and it's important to note when you're rearranging that you actually follow the rule of inequalities, and if you're dividing or multiplying both sides by that negative, don't forget to flip the sign. Okay, The next step, you'll graph it. All right, you're going to make the solid line or dotted dashed line accordingly. You're going to use a test point, okay, and this will make sense when I start doing some examples. I usually use 0, 0 to determine the region to shade. However, you may not pick a test point that falls on the graph, the inequality, so that the graph goes through the origin. So sometimes, if, say you have a line that goes through the origin, okay, we can't use a test point 0, 0, so maybe you want to use something like I don't know, 1, 2 or something, some other point that's not on the line. Okay, and then we'll shade the graph and then we'll check our answer on Desmos. Okay, so hopefully this will make more sense when I start doing an example. All right, our first example, it's in slope-intercept form. Gotta love that. So think of y is greater than mx plus b. You start out just like when you're graphing a line, identify the slope and the y-intercept. Okay, the y-intercept is -3. So this is where I like to graph from. Okay, start at your -3. Now again, your slope is 4, so that's 4 over 1. So remember your rise over your run. Okay, so I'm going to start at my y-intercept. I'm going to rise 4, 1, 2, 3, 4, and go over 1. 1, 2, 3, 4, and go over 1. And I do this a few times. Okay, or I could go down 4 into the left one. Okay, so there's the start of my line. I now have to look at the inequality symbol. So in this case, it's just greater than. So that means my line is going to be kind of dashed or dotted, all right, but it's not going to be a solid line, okay, because it's not going to include the values on the line. Okay, so it's dashed. All right, now the last step is to determine which way to shade. So we get to color now. All right, so you have two sides of this line. So looking at this plane right here, you've got the left side and the right side. We've got to decide which side to shade. The shaded area represents all of the solutions of the inequality. So what I like to do is just pick a point on either side of the line. I'll pick this one right here, okay, 0, 0, because to me 0, 0 is pretty easy to work with. You then plug it back into the inequality. Now the inequality we're working with is 4x minus 3. Okay, if I plug this in, my y value is 0 is greater than 4 times 0 minus 3. So 0 is greater than -3. That's a true statement. It is greater than -3. So that means the point 0, 0 is on the side of the line that needs to be shaded. Okay, so I colored this whole thing in. Okay, if it was false, then I would shade the other side of the line, but I want that 0, 0 to be in the region of being true. Okay, so actually every point on that side of the line would make this inequality a true statement. All right, let's look at number 4. All right, number 4 is an example where we need to start by putting it into slope-intercept form. So I'm going to start by subtracting x from both sides. I'm going to move over here. I get 2y is less than or equal to a negative x. And then I'm going to divide both sides by 2. Okay, so our y is less than or equal to -1/2 x. Notice I divided by a positive, so I did not switch or flip the sign around. Okay, you got to keep that in mind. If I was dividing both sides by a negative, I would flip the sign. Okay, so I identify my slope here, which is -1/2, and my y-intercept, which is 0. Okay, so my y-intercept, I start at 0. Okay, my slope is -1/2. So I'm going to go down 1 to the right 2, or I could go up 1 to the right 2, and I continue doing that. Okay, I get my kind of line going here. All right, I look at my inequality. I see that it's less than or equal to, so that means I'm going to make a solid line. All right, so I make my line. Oops, there we go. Okay. Now I've got to decide which side to shade. But if you notice, 0, 0 is right on the line. So I can't use that as a test point. So maybe I use the point, let's say 2, 2. Maybe I check this side right here at 2, 2. And it doesn't matter what point you pick. It can be anything. Okay? So we'll use 2, 2. All right. So when I check 2, 2, I actually plug it right back in. And again, it doesn't matter if I plug it into the original problem, inequality, or it in slope-intercept form. Sometimes it's easier just to go back to the original. Okay, your x is 2 plus 2 times 2, because your y is 2. Is that less than or equal to 0? 2 plus 4 is less than or equal to 0. 6 is less than or equal to 0. Well, 6 is not less than 0. So that means we need to shade the other side of the line. So this 2, 2 is in the fault side, so we don't want that shaded, but we shade the opposite side. So it will look like that. Okay? All right, if it was true, we would have shaded the side with 2, 2. All right, let's look at the next one. Okay, the next example, we have y is greater than or equal to 3. Well, there's only one variable. Y is greater than. We're going to think, just like with linear equations, this is our special case, our horizontal line, because we're going to think of y, because think of y, okay? It's a horizontal line at y is greater than or equal to -3. Well, what we do here, it's actually pretty easy. We just go to -3 and we make our y-intercept. It's a horizontal line, and I look at that inequality sign and I realize it's solid, so it's going to look like this. Okay, and since it's everything greater than that, since this is the y-axis, okay, all right, you can think of anything greater as being above it, okay, or if you need to check that, maybe you have a hard time visualizing that, but if the number line here was -3, everything above or to the right would be greater than. But you can also go and check a point, so maybe again I'll check 0, 0, and if I plugged in 0, 0, my y is 0. Is 0 greater than or equal to -3? That's true. So that means that it's going to be shaded on that side. Okay? All right, let's try the other kind of special case. Here we have x is less than or equal to -1. So we're going to think of x. Here we have our vertical line. Our x is -1, so we're going to go to -1 on our x-axis. We're going to make a vertical line. Again, it's going to be solid. Okay, now think of the number line. Your x value is less than or equal to -1. So less than would be to the left here. But again, let's check it out with a point. If I use the point 0, 0, and I plug it in, I end up with 0 being less than or equal to -1. That's a false statement. So that would mean I'm going to shade this side of the line. Okay? And then our last example that we have, number 7, we're going to start by putting it into slope-intercept form. 4y is less than -2x plus 8. We're going to divide by 4. Y is going to be less than -1/2 x plus 2. Our slope is -1/2. Our y-intercept is 2. So we started at our y-intercept of 2. And our slope is -1/2, so we're going to go down 1 to the right 2, or up 1 to the left 2. Okay, and because it's less than, we're going to make a dashed line. Okay, we made the dashed line there. Now we need to decide which side to shade. So 0, 0 is not on the line, so I'm going to use 0, 0. And I'm going to go back to the original problem and plug in 0, 0 just because I'm not dealing with fractions. So that's fine. You could use the original or the reformatted in slope-intercept form. But I plug it in. I've got 2 times 0 plus 4 times 0 is less than 8. Well, this is just 0 is less than 8. That's a true statement. So that means everything where the 0, 0 will be shaded on this side of the line. Okay? So I hope this helped. Now the last step that I really didn't get into, but I really like to show you, is actually making sure that we check our work on Desmos. Desmos is a great tool. Okay? So I'm going to pull up Desmos right now. Let me see if I can easily pull it up here. Whoops. Okay. It's not quite there. Let me get to Desmos.com and pull that up and let you guys see it. Whoops. Okay. All right, going to Desmos. I'm going to go to the graphing calculator here. I'm going to kind of move it around a little bit so you guys can kind of see it. See if this screen will fit it in there. There we go. Okay, so you can see right here, I'm going to put in the actual last problem we just did. 2x, and I'm just going to go to the original, plus 4y. The thing that's nice about Desmos, you don't even have to put it into slope-intercept form. Okay, so there it is. All right, whoops, can't really see the graph. Let's pull it over in the screen for you guys. Okay, I'll move it over. So if you notice, after I graphed it, okay, we've got the dashed line, and it shows which side to shade. So Desmos is really a great tool. All right. All right, so I hope this video helped you, and if you have any other questions, um, please just ask. Come for extra help on Mondays, or be sure to stay during Learning Lab, okay? Thank you. Bye-bye.